Hi guys, just another quick video. I wanted to show you another one of my apps called Distributions. It's about statistical distributions. You'll find it on the App Store under my name, or just search for Distributions and look for that icon. Just going to open that up. And really this has a whole bunch of both discrete and continuous distributions. I'll scroll through here so you can see some of them, like the Bernoulli, the binomial, uniform, hypergeometric, negative binomial, the Poisson. And for any of those, you can tap on it and you can see basically a description from Wikipedia. You'll see the probability mass function and the cumulative distribution function. Just some examples with the parameters there, in this case for the Poisson, the lambda parameter, as well as then the probabilities, where you can play around with the lambda and see how that changes what the shape of the distribution looks like. This is why it's an educational app. I mean, really to give you a good sense for what that distribution looks like. You know, sometimes it's difficult to sort of visualize these things. This is just a beautiful way to sort of see that information. You can also tap and drag along the charts, and you can actually see the probability at each of those discrete points for a discrete distribution. Scroll down further, you get the descriptive statistics like the mean, median, mode, standard deviation, variance, the skewness and excess kurtosis, as well as if you wanted to generate a random sample from this distribution with that particular lambda that you've set up there. So in this case, lambda equal to 5.5, and depending on how many values you want to generate 100 values, just tap that generate button, and there you've got 100 values from the Poisson distribution. You can see what the sample statistics are. If I go to the continuous distributions, you'll see, and here you'll see them grouped like you did with the discrete distributions around those with finite support, so the beta, the continuous uniform, the Kumarasamy, and then with finite, semi-finite support, infinite support, chi-squared, exponential, f, gamma, log normal, Pareto, Weibull, and then with infinite support, Cauchy, Laplace, logistic, normal, standard, normal, student T. So for any of these, let's go into the gamma. Again, a similar sort of thing. You got the definition at the top from Wikipedia. You got a couple of examples of the parameters. In this case, you've got 2 parameters, and you can play around with those parameters and see how it changes the shape of the probability density function in this case, and the cumulative density distribution function. You can drag your finger along and see the probabilities, as well as the descriptive statistics, and generating a random sample exactly the same as for the discrete distribution. So just a nice tool to play around, get to know the distributions. Enjoy. Thanks.